more content tomorrow.
All right. We are going to start with problem number 1. And the first thing you have to ask yourself is this law of sines or law of cosines? All right. So look at the problem and look at what measurements you're given. So you're given the measure of side little b. You're given the measurement of angle B. You're given the measurement of angle C. Do you have one complete opposite pair?
No. Yes.
Yes, you have both of the B's. So since we have a complete opposite pair of parts here, that tells us to use the law of sines. All right, let's go ahead and start with that complete pair. So let's start with the ratio of the B's here. So sine of angle B, which is 34 degrees, over side B, which is 19, equals, right? Now, the instructions say to find AB. We know side AB also as little c, right? This side here, AB, is also little c because it's across from angle C. So my ratio that I need to set this equal to needs to be the ratio of the c's. So this would be the sine of angle C, which is 114, over little c. Now this should bring up a big red flag. What I just wrote here should look very strange to you. Why?
It looks normal to me.
Okay, think about the chart that you looked at the other day with the sine, cosine, and tangent values. What is strange about what I just wrote?
Oh, it's over, what's it called? Like, not over 89.
Yeah, we're looking for the sine of 104. That doesn't even make sense.
It's goofy.
The sine of 114 degrees. That doesn't make any sense to us, does it? It doesn't. All right, take your calculator out and type in the sine of 114 degrees. 0.9135, is that what you're getting?
Yeah.
Look at the chart.
That's because the sin
Look
of
at the chart.
114 is equal to the sin of 66.
Sine.
Same thing.
Okay.
Oh, because it's the opposite.
You'll notice that the sine of 66 degrees is also 0.9135. And I don't have time to go into the y's right now, but the sine of 114 degrees is equal to the sine of 66 degrees. They're the same value. So your calculator still does not understand what the sine of 114 is because it doesn't make sense in right triangle trigonometry. It's actually just spitting out the answer for the sine of 66 degrees. Tell me how 114 and 66 are related, though.
They have the same sine, cosine, and tangent.
Yeah, they have the same sine value, but they have the same sine value, but I mean, how are those angle measurements, Riley? What do you see? Yeah. Good job. Those angles are supplementary. So the supplementary angles have the same sine value. So your calculator is really just spitting out the value for the sine of 66. And maybe we'll have time to go over that another day. Why those two? That's a different lesson. Why are they the same? All right, so let's cross multiply this and get C all by itself before we bother to put anything into our calculator. All right, so when we cross multiply, you get C times the sine of 34 degrees equals 19 times the sine of 114. I need to get C all by itself, so what should I do? Yep. So if I divide both sides by the sine of 34 degrees, I have C by itself now. So I can just type all of this in the calculator just like that. So do 19 times the sine of 114, close parentheses. I don't want that sine of 34 in that parentheses there. That wouldn't work out very well. And then divide by the sine of 34. And so little c is 31.0 inches long.
Why could you just cross multiply? Okay, you just did it weird.
Yep, right.
Why is it weird?
I just didn't set it up like
Do you understand?
that.
Okay, let's look at number 2 is exactly like number 1, so we're going to skip it. So the number 1 was about finding a side using law of sines. Number 2 is finding a side, but do we have a complete opposite pair of parts?
No.
We do not. We have angle A, side little c, side little b, but we do not have a complete opposite pair. So that tells me we're going to have to use the law of cosines. Angle A is the angle that's involved, so we're going to use the version of the law of cosines that has A bookending the formula. So that would be A squared equals B squared plus C squared minus 2BC times the cosine of angle A. And we're just going to fill in all of the values that we know, and then we'll see how we take care of this. So little a, do we know that?
No.
No. So that is a squared still. All right, set it equal to b squared. So little b is 16 plus 18 squared minus 2 times 16 times 18 times the cosine of angle A, which is 96 degrees. Use your calculator wisely, guys. You could sit here all day long trying to calculate every little piece of that, but
You can just plug it into the calculator.
you could do it all in one step. Some people like to do it in 2 steps. I just do it in 1 step. So I just go ahead and take the square root to begin with. Because I have to take the square root of both sides to get a by itself, right? So a is going to be equal to square root of all of that stuff. So I'll type that all in my calculator as it's written.
Why are you square rooting it?
So because a is not, on the left side it says a squared, it doesn't say a. I want to get a all by itself. So I'm going to have to take the square root of both sides. All right, so I'll type this in my calculator as it is. The square root of 16 squared plus 18 squared minus 2 times 16 times 18 times the cosine of 96 degrees. Press enter. You should get 25.3. If you didn't, start over. Follow the steps of what I'm typing into the calculator. Try it again. And it's 25.3 centimeters.
You dropped that.
Okay, so far we've found sides using law of sines and law of cosines. Next we're going to find angles using law of sines and law of cosines.